Hello, very good morning students. Let us take a review of last lecture in which we have seen the working of a common emitter amplifier and which is a voltage amplifier, and being a common emitter amplifier we have found that the input is connected between base and emitter terminals and output is taken between the collector and emitter terminals. There is a phase shift of 180 degree between input and output, and we have seen that the output voltage can be controlled by or can be varied by varying a RC. So these are the things which we have seen in case of a common emitter amplifier. We also have seen the design steps for the common emitter amplifier. We also have gone through the effect of varying RC and RE on the operating point of the common emitter amplifier. In continuation with this, now we'll go for the next circuit, which is a common collector amplifier. It is also called as a emitter follower. So let us look at this circuit diagram, which is a circuit of common collector amplifier. So what we do find in this circuit compared to the common emitter amplifier, resistor is not connected and resistor RC is not connected and collector is directly connected to VCC. Rest of the components are as it is. R1, R2 bias the transistor biasing, and it's a voltage divider bias. Whereas C input and C outputs are called as a coupling capacitors. C input and C out are called as a coupling capacitor. RS is the resistance of the input signal source. Then looking at this circuit, we don't come to know that why this is being called as a common collector amplifier. Now let us look at the AC equivalent circuit of this common collector amplifier, wherein while drawing a AC equivalent circuit diagram, so all capacitors will act as a short circuit and DC terminals or DC supplies are being found at the ground potential as far as AC signal is concerned. If we do look at this circuit, AC equivalent circuit diagram, we do find that input is being connected between the base and collector terminals of the transistor and output is being effectively taken between the emitter and ground terminal. So since collector is at the ground potential, so we can say that the output is taken between the collector and output is taken between the emitter and collector terminals. Output is taken between the emitter and collector terminals, and whereas input is connected between the base and base and collector terminals. Now let us list out first what are the points which are there associated with the common collector amplifier. As I stated, resistors R1, R2 are used to bias the transistor, that is to choose the operating point. This is already I have stated. This is also we have seen output is changed. Now we'll concentrate on this. Output voltage is equal to the IE into RE, or which further can be expressed as beta times IB into RE. So we do find that there is no phase shift between the input and output, and because of this is being called as a emitter follower, as the emitter follows the input. Now we'll look at the last sentence. Here it is stated that if we neglect the drop across base emitter junction, the output voltage is approximately equal to the input terminals. So if we do look at this circuit diagram, so wherein we have found that input is connected between this terminals, base and ground terminals, and this signal will come to the base of the transistor, and we do find a very little drop will go between the base and emitter terminals, and rest of the signal is available as an output across the RE terminal. So with this we can say that this amplifier provides the unity gain. As far as voltage is concerned, it provides a unity gain. Now we'll just look at the features or say characteristics of the common collector amplifier. So as I stated, voltage gain is approximately unity. High current gain. So how to get an idea of the high current gain? If we go back to the circuit diagram, so we do find input signal is connected between base and ground terminals. So will produce a small base current. So whatever input is available, whatever input is there between the base and this terminal is available across the RE, but now the input signal is being transferred from the low current and low current to the high current, because we do find that this voltage is being made available across the RE and current flowing through this RE is equal to the IE. So naturally the signal is being transferred from the low current area to high current area. So this signal then further can be used to drive the output load which can be connected between these two terminals. So these symbols also indicates there is a phase shift of 0 degrees between the input and output terminals. So this is about the working of a common collector amplifier. Next time we'll see the design of common collector amplifier. Thank you.